boys and girls, it's Mrs. J. Thanks for joining me again today for another edition of Sideways Math. I hope you've had an opportunity to look at the other video that I posted, the one that's a refresher about perimeter and area. If you haven't had a chance to look at that video yet, you might want to, because this is actually the second video. In this video, I'm going to be going over the answers and how to complete these two worksheets correctly. So you may want to look at the other one first and then come do these as activities. And remember, you can always do these ahead of time and use this video as an answer key to check your work. You can do your work along with me. If you have blank paper because you don't have them printed, you can just do the problems on paper or take notes. Any way that you can right now to help you get your math accomplished, is great. So do what you need to do. The first video that we're going to start with is the 5-1 reteach. The 5-2 looks like that. It's a little bit more focused on area. So we're going to save that one for second. So we're going to start with this one, the 5-1 reteach. Okay, so I'm going to label this answer key. And to start, I'm going to just put a little reminder up here on the top of our paper. Remember, when we do perimeter, we want to think about counting up the distance around the outside of our object. And when we do area, we're talking about the inside space that that object takes up. Okay, so we're talking about going around the outside of an object, and we're talking about the inside space of an object. And remember, whenever we talk about area, we talk about counting squares. So your label must always have squares. Okay, so let's look at the first problem. They've given us a little hint about counting up the spaces around the outside, because I see already a 4 and a 2 and a 4 and a 2 added up in centimeters. So I know that that's the label that we're going to be using for this problem. So let's see where they got that from. So if I count across the top, I count 1, 2, 3, 4. So that must be a 4. 1, 2, 1, 2, 3, 4, and 2 more spaces. So if I count all of those spaces up around the outside, I have 4 plus 4 is 8, plus 2 is 10, plus 2 more is 12. So my perimeter would be 12 centimeters. So this would be 4 spaces on this side, 2 here, 4 here, and 2. And remember, like our P, we're adding up around the outside to get perimeter. So that's how we came up with 12. Now remember, area, we're counting the spaces on the inside. So we're counting the inside spaces of our shape. So if I just counted my inside space, I'd have 1, 2, 3, 4, 5, 6, 7, 8, and we can see I have a 2 times 4, 8. And remember, I'm counting squares. I'm counting these squares of space inside my shape. So I'm going to draw it like this. And this is kind of where we get the multiplication fact from when we have an array. And this is why we can multiply 2 times 4, because 2 down and 4 over gives us 8. 2 times 4 is 8, and I have square, and my label is centimeters, so I'm going to label that square centimeters. So there's our answers for number 1. For number 2, my perimeter, we're going to go around the outside. And for perimeter, I always like to remember, I like to put a little mark. That means that I've counted that space, and I don't forget to count any spaces around the outside by accident. Because, sometimes you might count here, you might start here, here, and you don't want to miss any, and you don't want to double count any either. So that's just another little way for perimeter to help you keep track of your answers. So remember, we're counting the space from here to here. So that's why I'm putting a dash mark in the middle between the dots, because we're not counting the dots, we're counting the spaces. Because remember, if this was a block, we're counting one side of the block. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 centimeters. Okay. So I would have, if I made this, I'll make this into an array so that you can see it a little bit easier, so that you can see where those blocks and those sides came from, and that might help you a little bit when we go to our area. Okay, so when I put a dash mark, I was counting the sides of the blocks on the outside. So if you can kind of imagine this was a big table and this was a person, one person sitting in each of those spots all the way around the outside of the table. So I had 18 of those. Now for area, I'm going to count the spaces on the inside. So now I'm going to count the squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So I have 20 blocks total on the inside, and that's what gives me my area. So if I was to count this, the blocks up the side, 1, 2, 3, 4, 1, 2, 3, 4, 5, 1, 2, 3, 4, and I would have 1, 2, 3, and I would have another 5 down on the outside here. So to get my perimeter, I added up the 4 and the 5 and the 4 and the 5, and I got 18. To get the area, I did length times width. I did 4 times 5. Okay, so remember the difference between going around the outside and counting the number of blocks on the inside. All right, so number 3, this is one of those unusual shapes. Remember that I told you, you might not always have a square or a rectangle. You might have an unusual shape. And that's when it's especially important to make sure that you don't skip any sides when you're going around the outside when you're counting perimeter. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and I don't see a label on this problem, so I'm just going to label that 14 units. And now for area, I can't really do a multiplication problem because this does not make an array, so I'm just going to count the boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9. So the area of this shape is 9 square units. Okay. Now for 4 and 5, they wanted you to draw your own shape. So this says I'm going to draw a rectangle 4 centimeters long and 4 centimeters wide. So I need 4 blocks across and 4 blocks down. So you're not counting the dots. Remember, you're counting the sides of the blocks. So 1, 2, 3, 4, and then 1, 2, 3, 4, one, 2, 3, 4. Oops, they didn't quite connect. 1, 2, 3, 4. Okay, so there's my shape. It's 4 by 4. And if I were to actually draw that out, you could see my array once I connected those dots. Just using a straight edge, just so they look a little nicer and neater. Because you know, sometimes I don't always make the best straight edges, do I? No, they look like a bumpy road sometimes. Okay, so I needed to have a rectangle 4 centimeters long and 4 centimeters wide. So I have 4 by 4. Now, if I were to count the perimeter, I would count the sides of each of these squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So my perimeter is 16 and my label is centimeters. So that is the length of the distance all the way around the outside of the shape. Now, if I count the area, the squares on the inside, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Look at that. This is kind of one of those unusual ones where the perimeter does match the area. And I'm counting squares and I have centimeters. So there's my perimeter around the outside, my area on the inside. And number 5, they want us to make a rectangle 5 centimeters long and 2 centimeters wide. So I'm going to use my straight edge again, just so it comes out a little nicer. And I'm going to count 1, 2, 3, 4, 5. Because remember, you want 5 sides. Don't count the dots, because if we only counted 4, 1, 2, you want extra. 1, 2, 3, 4. 5 sides, so you actually have to have 6 dots. Remember how we talked about you always have to add that extra one on there to make it add up right? All right, so there I'm going to do this, and then I'm going to have my 2 going down and my other 2 going down, and then I'll just quickly, yeah, see, my lines are not as nice when I don't use a straight edge, are they? I'll make a complete rectangle. So there you go. All right, so I have 5 by 2. To count my perimeter, I'm going to go around the outside and mark the edges. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So my perimeter is 14 centimeters. That's the distance in length all the way around the outside of that shape. If I count the inside though, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. My area is smaller. I have 10 square units because I have 2 going down. I have 5 going over. And if I multiply 2 times 5, that should remind you of an array. So there's reteach 5-1. Whether you did it with me or you were using it as a correcting worksheet, I hope you did well on it. Let's take a look at 5-2. Now this worksheet concentrates mostly just on area. So this one's a little bit different. And you can see up here at the top, they've given you a rectangle with the imaginary lines on the inside to make the array, so you can kind of visualize those squares in your head. And they've shown you you can either do 3 times 5 or 5 times 3, because you do get the same answer when you do a multiplication problem if you flip-flop the facts. If you remember, that was a certain property. It starts with a C. Do you know what it is? The commutative property. Yay, the commutative property. I knew you knew what that was. So you'll end up with the same amount of blocks when you do the area, no matter which way you add. You could do 5 plus 5 plus 5, or you could do 3 plus 3 plus 3 plus 3 plus 3. You're going to get the same answer. All right, so let's look at numbers 1, 2, and 3, because these rectangles are a little different now, and that the numbers are bigger. The labels are all different, and they're obviously not drawn to scale, right? Like this one's in centimeters, this one's in feet. That rectangle is not 18 feet. And this box is inches. That's definitely not in inches either. So the labels are all different and unique, and it's not drawn to scale, but we can still figure out what the area would be of these objects, let's say, if they were true to life and to scale, okay? So all we're simply going to do is we're going to pretend in our head, we're going to visualize that there's an array like this inside that shape, and we're going to simply multiply the 6 and the 8, and you can see our answer here is 48 square centimeters, and you have to have squares because we're counting the blocks on the inside, remember, okay? So if we go to number 2, we're going to simply multiply 10 times 18. And if you remember, when we multiplied numbers by 10, we add an additional 0 to the ones place. So we have 180 square feet. So if I were actually to take the time, and I could make 10 blocks this way, 18 blocks that way. They would be teeny tiny little blocks, But if I counted them all up and I had an array, there would be 180 squares in that shape. So that's my area. Number 3, if I did 6 times 6, and I could visualize in my head that that was an array, 6 times 6 is 36, and that would make 36 squares. And I'm going to look at my label. They would be in inches. So if I was to draw 6 lines this way, 6 lines that way to make my blocks, I would have 6 blocks going this way, 6 blocks going that way. I would have 36 squares total. All right, so there's the answers for 1, 2, and 3. I hope you got all of those correct. Make sure to give yourself extra points for square with the label. And make sure that you have your multiplication fact answers correct too. All right, so this problem down here is like the one that I showed you on the chart paper. Remember where we take a whole and we can divide it into 2 shapes? You know, maybe somebody has a garden and they want to plant one kind of vegetables in this part of the garden and one kind of vegetables in that kind of the garden. Or maybe they're putting flooring in their house and they want to do tile over here and carpet over here. And they need to figure out how much they need total. Maybe the numbers are really big and the numbers for the length and the width you can't multiply. So if you divide them into smaller parts and you have 2 halves, maybe those figures might be a little bit more manageable, and then you could do those multiplication problems, and then all you have to do is add the 2 parts back together and you end up with your whole. So if we take a look here, one thing I always like to do is I always like to figure out what the total length is so I know what I'm working with. And this is where my first problem comes from. 3 times 6 comes from 3, 6, because 2 plus 4 is 6. But if you look at the problems that are broken down for section A, I would have 3 times 2. And then for section B, okay, because we would draw a line down here. So this part is 2 feet. This part is 4 feet. I would do the 3 times 4. And remember, if you want to put a 3 over on this side and pretend that this is 3 times 2 and 3 times 4 this way, you can, because the lengths on the opposite sides are equal. So 3 times 6 would give me 18 if I did the whole area problem. If I divided it up separately, 3 times 2 is 6, 3 times 4 is 12, and if I added that up, I would also get 18. Remembering, of course, that I had to put square feet. So that's the first example of how to take 2 parts of a problem with area and put them together to figure out the whole one. So we can do that with this problem too for number 4. So I always, like I said, I like to add this in my head so that I have 9 feet total. So if this was rectangle A and that was B, my full total would be 4 times 9, and I would have 36 for a total. And then if I was to do my 2 little rectangles, I would have 4 times 6 equals 24, plus 4 times 3 equals 12. And if I was to add my 24 and 12, I would also get 36. And of course I would put square inches, square inches. Okay, so those are just examples there to show you you can either take area with the full length and width and multiply to get the answer in one shot, or if for whatever reason, if you have a different shape with 2 different halves and you have 2 different areas, you can put them together to get the full area of the whole shape. All right, so for numbers 5, 6, and 7, these problems are kind of unique, and I like these because they want us to work backwards, so this is different. So in these problems, they have given us the total amount of area, and what we have to do is we have to work backwards because we have one part of the multiplication problem, but we don't know what the other side is. So here, so we have 4 inches here, but we have nothing there. And we have 7 centimeters here, but nothing over here. But we have the total answer. And what you know about multiplication and division is you just have to find that missing number. All right, that missing factor. So 35, if I think about 35, 7 times what is 35? Well, I know that that's 5. So 7 times 5 is 35. So if I was to turn that into a division problem, 35 divided by 7 is 5. And they already have that written down for you, so you can just trace over that. 5 centimeters. Okay, and we're just going to put centimeters because we just want the length of the one side. We already know the area and it's already labeled square centimeters, so don't put square on your answer. Okay, all right, so now I have 36 and my one number is 4. 4 times what equals 36? That would be 9. So my last answer to fill out this problem would be 9 inches. So I would have 36 divided by 4 equals 9 inches. Yay! Okay, give yourself a star for that. Woohoo! And our last problem for our video today. I have 56 square feet, but one of my lengths is 8. But what's the other side? Well, I know 8 times 7 is 56. So if I work backwards, I would have 56 divided by 8 equals 7, and that label is feet. So we're going to make sure that we're going to label that in feet. All right, so boys and girls, no matter which way you did this video with me today, however you were able to work out your worksheets, I hope you did well. I hope you had success with this. And remember our little tips and tricks for perimeter and area. Perimeter is matching or adding up and finding the distance around the outside of an object. Area is finding the measurement inside an area, inside a shape. And you always want to count the squares. So you always have to have square in your label. So thank you for joining me again for another edition of Sideways Math. I hope you had fun with this, and I hope you like perimeter and area.